golden triangle. I use this in chemistry, but it can be applied to just about anything in the scientific world. And so today we're going to apply it to one of the phenomenons we saw last week. But let's talk a little bit about how the golden triangle works. And I got the tribal council up here because you know what? It's guys like these that use this kind of stuff to have a deep understanding of science. So here we go. The very first thing is we always have some kind of phenomena that we're examining. And a classic example is what's going on around us right now with the COVID or coronavirus situation. That phenomenon is being tackled by scientists all around the world, and they're trying to figure that out. They're looking at the phenomenon that they see in hospitals, that they see in terms of how the disease is spreading. So a lot of things going on with that particular situation there. Not only are they going to have a deep understanding of the phenomenon, but they're also going to be able to apply different things to that. They may try to apply particle diagrams. And in this case, we know the virus is really small, so they're going to be able to sketch that out if they have a true understanding of how this COVID virus works. And they're going to have a better, and they're going to be able to draw like zoom bubbles and show like it super magnified things. You're going to be able to look at it and show you what how it works. They can also, scientists are also going to be able to apply what we call formulas to what's going on. I know that in the news, they've been talking about something called R naught, and basically that is a mathematical formula for how fast a disease spreads. And in this case, the COVID virus spreads very, very quickly and can spread to a lot of different people. So if you're a scientist and you're involved with studying the COVID virus, you're going to have a very deep or true understanding of things if you can work with all three parts of the golden triangle. So that's what we're looking at with this. Well, let's apply it to something that we looked at last week. When we were looking at with our situation last week, we had a phenomenon that we witnessed in a video. We watched BTB go from blue to yellow when Ruby breathed into it. Now, one thing that we're going to be able to do from that is we're going to be able to start to apply or show particle diagrams or models. In this case, we're going to use a molecular model kit to show what's going on with this situation right here. So that's one thing that we're going to be able to do. And we're also going to be able to apply a formula to this situation as well. So if we can do all three of these things, we're going to have a pretty good idea of why did the BTB turn yellow when Ruby blew into it last week. So let's dive into the first one, which is let's get into the actual model or molecular situation and what's going on when she breathes into this. All right, so we're going to start by, and again, you can always pause the video if you want to draw these things out. You can draw them out using circles and coloring them in with colored pencils. Not a bad idea. In class, you would be building these models with with your hands. But around the house, it's not a bad idea to grab some marshmallows, grapes, something, and actually build one of these molecules, and you'll have a better understanding of how it works. But we're going to look at it on a slide for right now. All right, so let's talk about our first molecule here. Our first molecule, some of you may know this, but if you don't, let me give it to you here. Get my pen out. The first molecule that we're going to look at is called carbon dioxide, and that's what a lot of people said is what Ruby is breathing out. And we know, CO2, we know that that's the gas that most people or most organisms are breathing out. So let's identify some of the parts to this molecule here. So we have one carbon atom, and that right there in our models is going to be this black atom right here. So that's our carbon atom. And then that carbon atom can form four bonds. Actually, carbon's a unique atom. It has four different bonds it can stick to things with. And in this case, it's bonded to an oxygen atom, which is right here, and another oxygen atom on this side. Notice that they're double bonds for both of those oxygen atoms that are sitting there. So that's one molecule that we know for sure is in this situation. Well, we know that oxygen, or this carbon dioxide, if she's breathing in the water, well, it's going to combine with water. And that's what BTB mostly is. It's mostly water. So we have our water molecule that's over here. We know that BTB is kind of like a side thing. It's just making a color change for us. So let's take a look at the water molecule, which is here. And in water, um, we have an oxygen atom here, same color as the one on the over here. So we have an oxygen atom there, H2. So we have the two hydrogens, which are right here. By the way, this is water. So let's H2O. And so we have a hydrogen atom there and another hydrogen atom there. Okay, so there's our water. So we know that when she's breathing into this, something's happening with these two particular molecules. So let's take a look at what happens. Well, they definitely are going to get rearranged, and what they're going to form is they're going to form a different molecule that's called carbonic acid. So let's write that down. Oops. Go back to that picture there and get my pen back out. And so we're going to call this carbonic acid. And as you can see here, it also has a carbon atom. I'm going to do this a little quicker here so you know what I'm doing now. An oxygen atom here, an oxygen atom here, and an oxygen atom over here. And then we have our hydrogens. Now, if you look at these, and we can kind of just draw a line here, if we count our atoms, they should be equal. Conservation of mass says that in any chemical reaction, matter cannot be created nor destroyed. So we need to have an equal amount on both sides. So let's count those up. On the left side, we have one carbon atom. And let's count up our oxygen atoms. On the oxygen side, we have 1, 2, 3 on the left side in terms of our reactants. By the way, the left side, remember, in this reaction, these are our reactants. And then over here, this is our product. So we have to understand that too. There we go. And then, so we're counting our atoms on this left side, and we have 1 carbon and 3 oxygens. And in terms of hydrogens, you probably all see this. There's 2. Well, what about this side? If these two are mixing up and forming a new compound, do we have the same number? Well, let's take a look. Yep. So we have 1 carbon atom, 3 oxygen atoms, and we have 2 hydrogen atoms. So it looks like we are all set in terms of our atoms are equal on both sides. So remember, atoms can never change, but molecules can. And let's see here. Okay, and our next thing is, now let's look at the formula thing that we have here. So we have formulas that we're going to look at. So the formulas that from that reaction, we have CO2 plus H2O forms or yields, in this case, carbonic acid. So now we have a formula equation that we got from that model that we showed there. So if we want to write the names of that, we can. So we have our carbon dioxide plus our water is going to yield or form carbonic acid. Now, if you remember in that situation of why BTB turns yellow, and if you add any sort of acid to it, it's going to do that. So the reaction of the carbon dioxide in her breath is reacting with the water and is what is forming that carbonic acid. And that's what's causing that BTB to turn that yellow color that we see when we see her breathe in. So we have the word yellow here. This is what causes that to turn that color. So that's a way to use that golden triangle. You're going to have a form to complete, which is next. Otherwise, have a great day, and we'll see you again on Tuesday, where we'll start looking at, again, what happened. We're going to start setting up the ethanol demonstration to prove what's happening. All right, have a great day.